Well, hello, wonderful students. This is quiz 508. It is operations with rational expressions. It covers adding, subtracting, multiplying, dividing, and complex fractions. So I wanted to make this help video one step at a time to talk about the different skills that you are going to need to be successful on this quiz and just the practice. So it is a lot. Let's get to it. Remember, you can use computer technology to help you solve this, but check each process. Check the big process steps in the computer program and by writing it out, either with a digital pad or on paper. Okay, so when we have fractions, regular fractions, if you remember, if we were to add or subtract, they had to have a common denominator, or in LCD, the least common denominator or the least common multiple of the denominator, the LCM of the denominator. Okay, so what does that mean? Well, we need to look at the fractions. We have 2x over x minus 2. Cool. That's basically 2x divided by x minus 2, but we can't do anything with that. We're going to subtract x plus 5 over x plus 3. Again, that's x plus 5 being divided by x plus 3, but this is simplest form, or the most useful form is like this. You could do other things, that's true, but we could do other stuff, but right now it doesn't help us. So what's going to help us is the same thing whenever we try to add or subtract fractions. Rational expressions are just a fancy fraction. We need a common denominator. So let's take a look. I have x minus 2 and I have x plus 3. Quick! A common misconception is, they both have x, so we just need to do plus 3 over here on the top and the bottom and minus 2 over here on the top and the bottom, right? Because those are the parts that's different. Common, incredibly common, still something that maybe pops in our mind to solve this, but that's not how it works, because x minus 2, x is a term, minus 2 is a term. X plus 3, x is a term, plus 3 is a term. They're not factors. What is a factor? It needs to be being multiplied. It needs to be multiplication. A factor implies multiplication. So 2 and x are factors because that's 2 times x. In fact, that's the only factors in this expression. It's just the 2 and the x because they're the only things being multiplied. Oh boy, I guess you could change it to, anyway, we could get into that in the form that this is, that's the only thing being multiplied. Okay, so there x minus 2 is the entire factor of the denominator on our first term, and x plus 3 is the entire factor of the denominator over here. So I need to multiply this side, top and bottom, by x plus 3. There we go, getting into the strategy. What you do is, if they have nothing in common, so if you factored and you see that they don't have anything in common, you just multiply by the other denominator. Same thing over here. Why can we do this? Well, x minus 2 over x minus 2 is 1. So we're essentially multiplying by 1. And when you multiply by 1, it keeps it the same. It doesn't change. It keeps it equal. Okay? All right, so now we will have x plus 3 times 2 times x minus x plus 5 times x minus 2. All of that over x plus 3 times x minus 2. Okay, hopefully you're following along, because this will help build that muscle memory of like, okay, what's going on? All we did was put it over a common denominator. Your answers will give you a clue. Always use that test-taking strategy. Always use everything available to you to be successful. But define success as understanding, not getting the right answer, or understanding as much as you can. Okay, so now we have a common denominator. Now we can subtract. Whenever you have common denominators, you just subtract or add the numerators, right? But we have polynomials in our numerator, so we need to simplify them. In this case, we're going to distribute, boop, boop, And we're over here, we're going to FOIL or use the box method. Okay? So what's going to happen here? This next step. Boop. Let's make it blue. I will get x plus 3 times 2x. So I'm just going to do 2x times x and get 2x squared. And then I'll get 2x times 3, which will just be plus 6x. Over here, I'm just going to use FOIL. X times x. So minus, keep that minus. I'm going to put a parenthesis because we have to distribute it once we're done. That subtraction, subtracting this whole thing. So after you FOIL it or box method, you'll have to distribute the negative sign. X times x is x squared. Okay, I'm going to do this up here. We'll get x times negative 2, so you get negative 2x. And then you get plus 5x, because I'm going to combine those. I know I'm always going to have a like term in the middle terms. So minus 2x plus 5x is plus 3x. Okay, I did x times negative 2, I get negative 2x. Then I did the middle terms, 5 times x, which is plus 5x. They combine, they simplify to plus 3x. And then finally the last terms, so first outer, inner, last, right? Plus 5 times negative 2 makes it negative 10. FOILing or the box method or multiplying binomials. Multiplying two binomials together is a common skill we're going to use until you're done with math, I guess. All right, the denominator stays the same. We don't need to multiply that out because of our answers. Our answers have a factored denominator, so we don't need to worry about it. It's also nice to keep it in factored form until you're done combining the numerator, the top part, in case the top part is factorable after you're done, and it has a common factor with the bottom. Let's go to green, teal works. Okay, so I'm going to distribute. This is going to become minus x squared minus 3x plus. And now we'll have 2x minus x, so we'll get x squared, 2x squared minus x squared, so then it becomes just 1x squared. 6x minus 3x, so we should get positive 3x, and then plus 10. Oh, that's factorable, I think. Let's see. Over x plus 3. No. It's not factorable. That's it. Because we can't get to plus 3. I saw 2 times 5 is 10. And then like 5 minus 2 is positive 3. But it would be negative 10 right there. So that should be our answer. Nice. So I have the factors switched on the bottom, but it's still equivalent. X squared plus 3x plus 10. Lots of work, though. We had to find a common denominator. We had to multiply our rational expressions and our rational terms. We made it a common denominator, then we had to multiply polynomials. Then we had to combine like terms and check for simplifying, okay? That's question 1. The skills will be the same no matter what you do. Okay, here's question 2. Which expression is equal to this? All right, it's division. Rational expression division. So division is the same thing as multiplication by the reciprocal, or keep, change, flip. So we're going to keep this one the same. However, I want to try factoring it. So let's factor the numerator and the denominator. If it's factorable, it might not be. I think it's going to be a c minus 2, c minus 2. How did I see that? Again, factoring skills. Look at that 4. It's a plus 4. So I need two numbers that will multiply to equal positive 4. Well, negative 2 times negative 2 is positive 4. I need to check to see if they combine to equal negative 4. Well, negative 2 plus negative 2, that's what I mean by combine, will be negative 4. So we're good. Let's take a look down here. What do they have in common? Oh, I think it's a 6. C, squared, right? 6c squared, because they both have c's. C squared is the lowest, so we can pull it out. They're both factors. The number parts are both factors of 6. This one will end up being 2c plus 5. Yeah, that looks it. That's all I can do. Okay, so now I factored the dividend, the thing being divided. So we keep that the same, but it's just in factored form. Change, yes, I'm still here. Yes. Okay, so the change part is we're going to change to multiplication. So remember we had our c minus 2, c minus 2, which you could write as c minus 2 squared. I'm just going to leave it like this, and then we have 6c squared times 2c plus 5. Okay, that's our dividend. That's this, it's just factored. I'm going to change this to multiplication. I'm going to flip this, but I'm going to factor it. So I'm going to start down here. It looks like a 3. Yep, not a 6. I almost took out a 6. 3c cubed times, so what did I factor there? I'm looking at the letters, right, the variable part and their exponents. I see they have a c raised to the power of 3 and a c raised to the power of 4. So the most that they have in common is 3 of them, c cubed. So I took out a c cubed. Then I looked at the number parts. What do they multiply together? Well, 2 times 3 is 6, and 3 times 5 is 15. So I'm going to pull out a 5. When I say pull out, I am dividing out. I think of it as reverse multiplication. So instead of division, I think what times 3c cubed will get me back to c to the 4th. So that's 2 times c. Because when I remultiply, when I redistribute, I'll get back to my original one. Okay, that's just what I do. Any method that you like will make sense. Cool. All right, now c squared minus 4, that's called a difference of squares. I see a c squared, so I know it's going to be c minus 2, c plus 2, because it's called a difference of squares. It's a factoring pattern. Okay, so when we multiply fractions or rational expressions, we just multiply straight across. So look, I can just make this one giant one and just be like times, times, times. So now it's all being multiplied straight across and on the bottom. Now they're all factors. If we have factors, now we can simplify. We can't simplify across addition and subtraction, but we can if it's multiplication. So here comes the fun part of canceling. I think we did this on the whiteboard. It's good fun. Here we go. We have a c minus 2 and a c minus 2. The whole thing in parentheses, right? So we can get rid of it. That'll work. Oh, we have a 2c plus 5, a 2c plus 5. And we have a c squared, c cubed, but we're left with 1c. Again, quick reminder, if we have c to the power of 3 over c to the power of 2, you can think of it as laws of exponents, where you can subtract however it makes sense in your brain. You can just think if you have more on the top or the bottom, just subtract from whichever side, and whoever has more, leave it where it is. If it's on the bottom and you took away, like if it was reversed and you had 2 on the top and 3 on the bottom, well, you take 2 away from the 3, leave it on the bottom. But the 3 is on the top, so you have 3, take away 2, leave it on the top. Okay, and then the number parts cancel. That will just become a 1, and this will become a 2. Ooh, snooze. Okay. And then we just look for what's left. It looks like we have a c minus 2 on the top times c. And we have a 2 times c plus 4 on the bottom. Right, because we have a c minus 2 times c, c plus 4 times 2. Let's go see. Let's go see. All right, I have it. Oh, yes, sorry, plus 2. Difference of squares factoring pattern. So a squared minus b squared will always factor to a minus b times a plus b. So they have to be the same number, right? C minus 2, C plus 2. My bad. So this should be A2. Cool. Hopefully that makes sense. So this one, look, the 2 and the C are flipped. This one, the signs are flipped. See the plus is on top. Yeah. Okay, cool. That was question 2. Lots of work, you guys. Here we go. We're not done. Question 3. Okay, we're adding. There's the answer, but let's see how did they get the answer. 3x over x plus 3 plus x minus 2 over x. Well, we need them to be common denominators. So I immediately look at the denominator. Do they have anything in common? Nope. So I'm going to multiply by the opposite denominator, right? We used to do that in math. We still do it whenever we had just numbers. Okay, plus. And then over here, we're going to do x plus 3 over x plus 3. Why? Because it's the denominator of the other one. Times x minus 2 all over x. Okay, that's the step whenever you add or subtract rational expressions. Same step you would do if it was just regular numbers. So now this will become 3x squared all over x times x plus 3, because now they have the same denominator. So now we just add plus, I'm going to FOIL this out, x squared. I don't have to worry about distributing the minus sign because I'm not subtracting, I'm adding. So it's a little bit easier. So plus 3x. Remember, FOIL is just a way of organizing our math, so we make sure each term is multiplied by each term, okay? And now we simplify like terms, so 3x squared plus x squared should be 4x squared. All right, so we know it's one of these two, right? 3x squared plus an invisible 1, x squared, 3 plus 1 is 4, okay? Then we have 3x minus 2x, well, that will just become x. So there's x. Okay, so far it's the same. And then this becomes minus 6. It just stays minus 6 because there's no other constant term to combine it with. So that's the only difference. One says plus, one says minus. And there you go. Nice. Okay. I was adding. What do you think this one? We did subtracting rational expressions. We did dividing rational expressions. We added rational expressions. Now we're probably going to multiply rational expressions. Okay. When we have multiplication, we don't need to do anything but kind of factor, okay? We want to simplify, so when we do that, we want to factor each of these, looking for common factors. So this 6a squared minus 30 looks like they share a 6 and an a times a minus 5, right? Because if we redistribute, we'll get 6a squared minus 30a. All of that is over a minus 2. I'm going to put it in parentheses just to keep it grouped. All right, times, I'm going to factor this one. Okay, so again, it's an a squared plus 2a minus 8. I look at the minus 8. I think to myself, what does it equal? We have 2 times 4. Is there a way to get to a positive 2 and a negative 8? Yes. If I have negative 2 times positive 4, I get negative 8. Great. If I have negative 2 plus positive 4, I get positive 2. So that's what it's going to factor into. So I'll have a minus 2, a plus 4. Snooze. Okay. The face up there. Perfect. Now what does this factor into? It looks like they have a 2 and an a squared. So I'm going to take out a 2 and an a squared. Again, when I take it out, I'm dividing it out, but I'm also just using the reverse distributive property. So I'll be left with a, because when I remultiply it, 2a squared times a gets me back to 2a cubed, and I'll be with a minus 5. Cool, now we start our canceling. Whoosh, 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 remember, that's 1 if I have a on the top over a squared, it's like there's a 1 here. So then this one basically goes away, and you take away 1 from the bottom, and you're left with an a. Okay, so we have this a. Oh, okay, so it should be 3 times a plus 4 over a. 3 times a plus 4, if I did my math correctly and I do it wrong, over a. Ooh. Okay. So then they just distributed. So if we just distribute, we get 3 times a, 3 times 4, so you'll get 3a plus 12. It won't let me scroll anymore. So if the denominator is just a, we did a good job. If it's not, I messed up. Oh, okay, good. Factor, multiply straight across, look for common factors, cross them out, I guess distribute, and you would see that this is the same answer. All right, last problem. Complex fractions. They're just fractions in fractions. That just means there's a fraction in the numerator, a fraction in the denominator, or in both. And now in our case, there's even going to be expressions with fractions. So let's just take a look at this first one and solve it. We want to simplify it. Well, the way you simplify it is you need to make sure this is one whole fraction, so you need to add them. Get a common denominator. You need to make sure the denominator, this whole thing, is one whole fraction. So we need to put these together to make them fractions because this just means division. It just means division. So then we'll do what we did in question 2. We'll just divide them. Once we get them as one nice fraction in the numerator and the denominator, how do we do that? Well, when we added or subtracted, you need a common denominator. So right here we have 3 over x plus 1/4. Well, we need the denominators to be the same, but we don't know what x is. If we knew what x was, we would just multiply by that number, the 1/4, and we'd multiply that other number by 4 over 4. That's exactly what we're going to do. So multiply this by 4 over 4, because that's a clever name for 1. When you multiply by 1, and multiply this by x over x, because when you multiply by 1, it keeps it the same. So this is all going to stay the same. It's just going to look different. We'll now have 12 plus x all over 4 times x. These can't cancel or simplify because the numerator, the top, is terms, 12 plus x. The bottom is 4 times x, right? Okay, so let's do it for this one. Well, 1, what do we do with 1? Whenever you have a number 1 and you're trying to add it to a fraction, whatever the denominator of the fraction you're trying to add it to, you just put that over itself. So the denominator is x. X over x is 1. It'll always equal 1. Even if it doesn't have an x term in it, that still equals 1. X divided by x for every value at every point will always equal 1. So they're equivalent. That is 1. I just rewrote it. So then you'll have x over x plus 3 over x. Okay? So then you'll have the bottom of our complex fraction will be x plus 3 over x. I'm going to pause here. All right. Okay, so we got to this point where we made the numerator 3x times 4 over 4 plus x over x times 1/4, right? That's what we did. I'm sorry for repeating. And so the whole numerator would become 12 plus x over 4x, right? That's what this top part becomes. Down here, we figured out, well, 1 can be written as x over x plus 3 over x. So that's just going to become, 3 plus x, or x plus 3 all over x. I'll write it as x plus 3 just because that's the order that it would have been in. It doesn't really matter, all over 3, or all over x, excuse me. Okay, so at that point, we have a complete fraction. It's all one fraction in the numerator, all one fraction in the denominator. So now it's just division. So keep, change, flip. 12 plus x over 4x. Keep the dividend the same. You change the divisor or the denominator to its reciprocal because, again, multiplication by the reciprocal is the same as division of the original divisor. Okay? All right, so we're multiplying, so I'm going to put some parentheses around. Cool. We have 12x times x over 4 times x plus 3. We're looking for common factors, so if you notice this x over x, they just cancel, and then we're done, unless they want you to distribute. But your final answer should be 12 plus x over 4 times x plus 3, or something like that. It could be 4x plus 12, but let's see. Nice. 12 plus x over 4 parentheses x plus 3. Thank you for watching. This took on a lot of skills. Lots of skills to complete this quiz. So please reach out if you have any questions. Check your work, check your answers, write down your work on paper so you can check your steps. If you get stuck, try out Symbolab. Reach out to me if you need any help with the technology that we're using. And have a great rest of your day.